Hello, this video will introduce our work in CVPR 2026, Region-Aware Instance Consistency Learning for Micro-Expression Recognition. The facial expressions we commonly refer to are known as macro-expressions. They can be controlled. In contrast, micro-expressions are involuntary and uncontrollable. Due to this property, micro-expressions can reflect genuine emotions that individuals attempt to conceal. However, micro-expressions cover facial activation regions with imperceptible intensity and brief duration. Therefore, the micro-expression recognition task remains challenging. So the first question is, how do we extract subtle motion? Motion between the onset and apex frames is often used to represent the subtle movements. However, this paradigm struggles with expensive apex annotations and small amount of data. So the second question is, how to get rid of a fixed apex and achieve effective utilization of micro-expression data. In this paper, our key insight is that the motion patterns show spatial stability and intensity variation. We observe that frames within the ME sequence exhibit motion patterns that share consistent spatial activation regions compared to the onset frame, while the motion intensity across these activation regions varies over time. Spatial stability reveals that effective motion information is not exclusively contained in the apex frame, while intensity variation enables data augmentation to mitigate overfitting. Based on the key insight, we designed the Region-Aware Instance Consistency Learning Framework, ROICL. It contains three key components: Multiple Instance Representation MIR, Instance Region Consistency IRC, and Multi-Region Discovery MRD. Based on the inherent nature of spatial stability and intensity variation, the ME sequence can be represented as a set of optical flow instances from the onset frame to arbitrary intrasequence frames. Furthermore, we fix the sampling range to the middle end frames of each sequence. This middle sampling strategy reduces computational cost and excludes the lowest motion intensity. Then the Siamese network learns to identify invariant activation regions for massive instance pairs, where the weak instances can learn from the strong ones. Driven by the spatial stability, the Instance Region Consistency IRC module locates invariant activation regions by flip semantic consistency. IRC first use class activation mapping to generate attention heatmaps for each instance. Then, the attention consistency loss is conducted between the attention heatmaps. IRC only recognizes the most discriminative regions, and some weaker but important activation regions are discarded. To address this issue, the Multi-Region Discovery MRD module uses a set of facial queries to discover meaningful regions by the transformer decoder. Based on the spatial stability between these discovered regions, the consistency constraints provide self-supervised learning signals. The alignment loss measures the consistency of probability distributions when assigning pixels to the discovered facial regions, and the cosine similarity is used to measure the consistency of produced local region embeddings. We conduct experiments on full public micro-expression datasets. Our method surpasses state-of-the-art methods without using any apex frame annotations. We conducted the ablation study under the CDE setting. Methods from M1 to M6 demonstrate the contribution of each design, and methods from M7 to M10 demonstrate the robustness of multiple instances representation using different sampling strategies. Methods M11 and M12 indicate that the model does indeed learn effective motion information from frames other than the apex frame. From the ablation study, we conclude that, first, with the ability of effective exploitation of the motion variety, ROICL no longer need apex frame annotations. Second, to promote practical applications of micro-expression recognition models, the effectiveness of multiple instances representation deserves further investigation. Attention heatmaps show that IRC keeps invariant attention across instances, and then MRD expands its attention to more activation regions. Thanks for your listening.